Okay, well, this is going to be the fast version, and I'm going to make a longer version, but review of the evolutionary biology of aging. Michael Rose told me to get this book, and I got it. And I told him if I bought this book, I'm going to read the whole thing, and I'm going to let him know what I think. I'll let him know what I think. So there's a big problem, a big logical flaw that runs through this entire book. And we'll just go over that, and then I'll go over every single minor detail later. So the flaw is all the bolded stuff. I keep seeing in this a lot of age-specific reproductive values appears that determine how natural selection influences individual mortality rates. There's a lot of what happened here was that there's a presupposition of aging, and then that explains the drop in the force of natural selection, and then you use that to explain aging. So it's I had it here. Good Lord. Okay, here we go. Aging induces the declining natural selection force, which then induces aging. This portion here is what the book is arguing, but they're assuming aging is happening in order to get to that point. And the reason why they're assuming aging is happening is because they assume there's some kind of a change in reproductive potential over like an organism's like lifespan. But that is aging. Like the change in reproductive potential is aging. So it's changing something. Something is changing in the organism over time in the sort of like a vacuum. In the case that like if the organism was at peak health, it would still be changing over time. That is what aging is. If the organism wasn't aging, reproductive potential would be a flat line. It would just be at peak or whatever for this entire existence, trailing off ad infinitum, which means that all the math and all the arguments that you make in this entire book don't apply because they assumes that there's some kind of a fall off of reproductive potential. And so if reproductive potential is infinite, then all of the antagonistic pleiotropy effects, all that kind of stuff, it goes like the math doesn't work out anymore. So we're going to go through all the bolded claims. So this reasoning reveals a key role in the age specificity of genetic effects. Again, why would there be age-specific genetic effects past development unless the organism was already assumed to be aging? In the action of natural selection on aging, we'll keep that bolded. The age Haldane implicitly bolsters the case for an evolutionary explanation of aging. Again, it requires aging to be a force first, then declining force of natural selection can explain aging. Let's go down. What causes the decline from B to C? It's not really explained. You're hooking it to reproductive changes, and that is like the foundation of what aging actually is. So I think it's like the whole book is like close, but it's not there. Here's another piece. They assume menopause always comes before age 45. You're detaching like menopause and aging, like reproductive aging, from aging itself, and that's the mistake that's being made in this book. Some more pieces from the book where it's clear that you guys are decoupling reproductive aging and aging for some reason. So about chapter 19, I was pretty confident that the book can be summarized as aging creates the declining natural selection force, which then explains aging. And then I had to read to the end to see if I was correct. A couple of other things. I'll go over that later, the math part. If aging can be involved in. Oh, yeah, this was an interesting point. So if aging is purely a product of natural selection, like if natural selection forces were the driving factor of aging, you should be able to push it indefinitely in one direction. You address this later in the book about how there's like a limit to it, but the thing is if there was a limit, then natural selection isn't the main driving force, right? You should be able to continuously evolve it in one direction indefinitely if the force of natural decline in natural selection was the main force or the only force, but it's not. And in fact, I would say that it's actually a minor force. The increase in lifespan that you can get from trying to evolve it in a specific direction is so minor compared to how long an organism is capable of living. I'm talking about the germline cells and the fact that they've had physical continuity for since the dawn of life, which is billions of years, and yet there's some argument to be made that getting a Drosophila to like live, I don't know, 30% longer or something is gonna like that's not even like close to being an effect for in terms of like aging versus non-aging, right? So that's my problem with that. Age at which mortality plateaus depends on the last age at which a population reproduces. Again, you're assuming reproduction is just this separate thing from aging, and they're like this. So yeah, if aging didn't exist, it would kind of be flatline after development. Aging stops at later aging cohorts taken from populations that have later last ages of reproduction in laboratory cultures. All of this is supporting the concept that reproductive aging is the foundation of aging. And this, yeah, this is funny. I'll go over it later. Let's see here. Anything that changes with age. Late life adult organisms and oh yeah, this is a different contextually late life here. I get that it's used differently than earlier in the book, but you might want to try to use a different terminology there. Hitchhiking effect. Okay, I think that's everything. I mean, that's not everything. I'm gonna go through the slower version for the next video, but that's the core for this book is that you've got 60 chapters here, and there's a big like logical flaw made in the very beginning, and it sucks that that happened. Sorry. I'm not saying that the book sucks. Actually, the book is very well put together. I like the structure of it, and I like how the concepts are explained, and then like the references are all like in the section where it's relevant to that. I think that the book is well put together, but there's a logical flaw in the beginning, and I think I've repeated myself enough times that you get it. So I'll just see if you want to respond to that at all or not. It's up to you, I guess. Cool. All right.